All right. Hi, everybody. How are you guys? Plan for today. We're gonna finish up these notes. I have like 3 or 4 more examples. We're gonna work through these examples much in the same way we did the last couple, where I'm gonna actively ask for your guys' participation. So to make that go a little bit more smoothly, what you're going to want to have out with you for said participation is this sheet of identities that I gave you last time. Does anybody need a new sheet that didn't get one? Oh my gosh, guys. Yeah, I think there's 4 that need to go in this direction. I mean, whose hands are over here? If anybody else changes their mind, they're like, yo, I do actually need that, sit right here and help yourself.
What action is this? What time does class go until?
I don't remember.
Okay.
Till the bell rings.
Okay.
And about an hour from now. 12:50, somebody says. That sounds like a good plan. I believe you. Okay. So, remember what we've been doing. We've been trying to talk about these simplifying trigonometric expressions, right? There's kind of 2 buckets that we can pull from in order of things to do. Either we have the algebra bucket that's like simplify and reduce fractions and make common denominators and combine like terms and factor and FOIL and that stuff. And we have the identity bucket that has the identities listed in front of you. Everybody's cool? So those are the tools that we can pull from in order of things for us to do. Typically, when starting a problem, the first thing I'm going to look for is to pull from the algebra bucket. So if I look at this one, I have cosine x over 1 minus sine x minus sine x over cosine x. Kendall suggests, let's make a common denominator because we have 2 fractions that are being subtracted. That'll allow us to take 2 things and smash them together into one thing. Typically a really good idea. So let's do that. If one denominator is 1 minus sine x and the other denominator is cosine x, what will the common denominator be?
1 minus sine x times cos x.
Yes, 1 minus sine x times cosine x. Those 2 denominators are relatively prime, so their least common denominator is going to be the product of the 2. So we'll do that. Everybody happy? What's cosine times cosine? Or cosine x times cosine x? Cosine squared x. And then what's sine x times 1 minus sine x? Well, I'm just going to write it this way for now. Look good to everybody on what we did?
You can't multiply sine x.
Well, we for sure can. I just wanted to wait for a second and see where we're at before going ahead and plowing ahead and doing that. Maybe something better will present itself than going ahead and doing that also on the same step. I don't know, but I want to give myself the option before making a common denominator and then multiplying things through. You know what I'm saying?
Yeah.
So I just want to make sure I take a chance to look. Okay. So we're looking. Kendall, you have an idea?
For the identities, we've modified the first one to be cosine squared equals 1 minus sine squared to make the entire top sine.
So I can make, we can do that. I would do this instead, though. I would do this instead. So yes, the answer to your question is yes. So Kendall says, that first identity says sine squared plus cosine squared is equal to 1. If I subtract this sine squared over, could I use as an alternative identity cosine squared is equal to 1 minus sine squared? The answer to that is yes, you can do that. If you want to write on your sheet next to P1 that has an alternative, that's a great idea. And if this is true, what else is going to be true? That sine squared equals 1 minus cosine squared, right, for the same reason. So I would write that next to my P1 also. So I have 3 different versions of P1 that you could use. That's fine. I would not do that here because I think what we're going to end up seeing is something equivalent or even a little bit quicker happens if we just distribute that sine x through as Addie wanted to do on instinct before. I think that's probably the better thing to do since nothing immediately is going to combine together by doing what you suggested. Gian?
I know that.
Of course. Okay. So this is all like an aside, right? Yes.
Since there's 1 minus sine on both the top and bottom, you're not allowed to
Correct. Because there's a subtraction in the numerator, right? So if you think about this, this is like 1 minus 2 times 3 over 3 times 4. If you did what you're suggesting and did that, well then we just end up with negative 1 over 4, right? Well, if I don't do that reducing, that's going to be negative 5 over 12. Are those two the same? Definitely not. So that's a way to kind of check, just replace everything with numbers and see if I do the reducing, do I get the same thing? If the answer is no, don't reduce that way. Does that feel okay? And that's a nice little easy, quick check if you kind of doubt your algebra. It's can I do that? Maybe. Let's check, right? Okay. I'm going to erase all this because it's kind of in the way of where I want to go. Instead, let's do this, which is what you wanted to do on instinct, which I think is going to be the nicest and fastest route to our final answer. So what do we get when we multiply negative sine x and 1? Negative sine x. That's kind of like a question, Mr. Kulik. Did you really ask me that? I did, because it's, it's pretty early. Let's throw some softballs out there and get your confidence up, right? And then we have negative sine x times negative sine x. What's that?
Sine x squared.
Positive sine x squared. Yes, so we'll have plus. And remember, we always we write it as sine squared x. Okay. Is there any more algebra stuff that we feasibly can do here? Not really, right? I mean, you could factor a sine from the two things on the top of the thing right back in where you were the previous step. So let's not do that. You could distribute out the denominator, but let's not do that because if I want to reduce the fraction at all, the denominator's got to be factored anyways. Almost never am I going to want to multiply a denominator out. So if we don't see any more algebra, what do we look for next? An identity, yeah. So if we look at what we have on here, what identity should, or what place is the best place to look for an identity to use? Good, yeah. Why did you say the Pythagoreans? Yeah, because we have the squareds and we have things being added and subtracted, right? So which Pythagorean seems like the one to go with? P1 is correct, because I see that I have a cosine squared plus a sine squared. What does sine squared plus cosine squared equal? 1. Is everybody okay with how I highlighted to denote what happened there? And maybe I'll highlight this thing too, right? Does that make it easy if you went back and looked to see kind of what I did? Trying very hard to notate this in a way that when you go back and look at it, you can follow what happened. Now we should notice something great has happened. What great has happened here?
One negative sine on the numerator.
So the 1 minus sine x, if I think about it as one whole thing, now we can do that. Addie, you see the difference between doing that and what you wanted to do? If I think about this as one whole thing, now it's okay to cross off because there's no subtraction going on because it's inside the thing,
Okay.
right? Before, when you wanted to cross off a part of the thing, ooh, that's not good because there's still this thing that hasn't been reduced from. But over here, just one thing on top, crossing out with one thing on bottom, and it's all multiplication. Now, when we cross them out, remember they become ones. So what are we left with then? 1 over cosine x. Which, ooh, that's pretty darn good. We're down to a single trig function, but still in a fraction. You want to like better than fractions? Not fractions. So, seems like identity time again. Where should we be looking at? Dan says at the reciprocal, so we should say that 1 over cosine is secant x. And there, we're down to a single thing. Can't get better than that. Woo. How do we feel here? It's going okay? You guys follow kind of what we're doing? I want to point out, yes, Nina.
Can I go to that?
Sure. I want to point out to you guys, though, as you're doing these and while you're watching and participating, there's not one path to a correct answer. Okay? I'm trying to shepherd you so that you stay on the shortest path to the correct answer because it keeps the problems feel more manageable. But when you're on your own and you're doing this, there's no penalty for taking like 12 steps when you could have been done in 5. Okay? As long as you're doing correct work, you're using identities properly, you're using algebra properly, and you arrive at the correct final answer, there's no deduction for doing it long, in a more circuitous route. Okay? There's no style point here is what I'm trying to say. Now, I will try to shepherd you guys away from, the scenic route. But when you're on your own, you don't have Mr. Kulik to kind of like, no, don't turn there. Keep going straight. Or like, hey, what are you doing? Like, turn off here. That can happen. That's okay. It's okay. All right, let's keep on going here. All right, we got a couple more examples, and then I'm going to sign off and hand out some worksheets and let you guys get started. Sound good? All right. 10x times cosine x. Is there any algebra I can do here? No. Okay. So it's identity time. Lots of identities that we could be using, but we're really restricted to the reciprocal and quotient identities because we don't have any squareds or any addition, right? And really the bottom 2 sets of identities you won't use a lot, and it'll be fairly obvious when to use them. And this ain't one of those cases. So probably the best route is to rewrite everything in terms of sine and cosine, would be the identity route I would go with. So to do that, I would look at my quotient identities and see that I can rewrite tan x as sine x over cosine x.
Why do you do the
Right, but it doesn't give me sines and cosines. It gives me 1 over cotangent. Is that okay? And since I'm multiplying fractions, I'm going to write it cosine x as like cosine x over 1. So that, because I know, how do I multiply fractions again? Tops to tops, bottoms to bottoms, right? But really, I'm going to reduce before I multiply here, because what do you notice? I have a cosine x on top and a cosine x on bottom. There's no addition or subtraction, so whoop, whoop, can cross those guys out all willy-nilly. And I'm just left with sine x over 1, or sine x. And I'm done. Whoa, Mr. Cooley, that was easy. Where's the Staples button for me? You guys are all probably too young to remember that commercial. All right, let's try 2 then. Cotangent u times sine u. Anything we can do algebraically? Nope. Let's use an identity. What's going to be the goal for our identity? We want to get everything in terms of sine and cosine, so let's use quotient identity 2. That allows us to rewrite cotangent as cosine over sine. And again, I'm going to rewrite, since it's now fractions, I'm going to write sine as sine over 1. And what do you notice happens? Yeah, like the same thing as the last one, right? Okay. Okay. I see where we're going, Mr. Gulick. This isn't so bad. They can be really straightforward. Can be like a 1 or 2 step problem. Not all of them. What about number 3? What do we notice there? Is there any algebra to do? No, it's already one thing, right? Okay, so what should we do next? Find an identity. So there's 2 plausible identity routes we could go on this. Where I see the 1 and the tan squared. My first place I would look is for a reciprocal identity. If I don't see that, then it's sines and cosines is what I would do. But I'm going to first start by looking, I'm sorry, did I say reciprocal when I meant Pythagorean? Yeah, I meant Pythagorean, because I have squared and the plus 1. So if I look at my Pythagoreans, what do you see?
Tan squared plus 1.
Secant squared, yes. So that's just P3. Feel good so far? Okay. Still nothing algebraic to do. I still just have one thing. I can't reduce that fraction because, well, they're different terms. So it's probably identity time again. anybody see a good identity to use in this case? Dan.
Quotient 1.
Quotient 1, yes. Notice that quotient 1 has two versions, right? So the first one says secant, or the second one says secant over cosecant is tangent. But we have squareds here. Does that make a difference? It's going to make it tan squared, but, you know, like, still can use it. Notice here on this one that no algebra was used, right? This is all just doing identities. This is Mr. Kulik attempting to like give you a variety of these simplifying problems where sometimes algebra is what you want to do first, sometimes identities is what you want to do first, and how you can kind of look at them and tell, right? So I always start by looking for an algebraic thing to do, but sometimes there just isn't anything to do. That's okay. When that happens, we go to identities. Is this helpful in kind of trying to build up some intuition about like where to start looking, what to do first? It's a little bit of a like, you gotta feel it out. So like we need to do some examples and then you're gonna need to have some time to like get a ticket on the struggle bus and kind of feel your way through this. But that's okay, that's okay. All right, last one. Sine squared plus tangent squared plus cosine squared all over secant squared. Woo! That's a lot going on there. Do we see anything algebraic to do? It's already one fraction. There's no like terms to combine. There's nothing for me to reduce. So the answer to that is no, there's nothing really to do here. So what does that mean? Identity time. Does anybody see a good one to use? Where are we going to start looking? We're going to look at the Pythagoreans, and P1 is the one that we would want to use. The reason we wanted to look at the Pythagoreans is in the numerator you had all those squareds and additions. Is everybody good that even though the sine squared and cosine squared weren't right next to each other, we can still use P1 there, right? Because you can add things in any order you want. Addition is commutative. That's the word for being able to do it in any order you want. Yes, Julius?
It doesn't matter if you put the one before or after. Right?
Correct. It does. It would not. You could write as tan squared u plus 1 or 1 plus tan squared u. Again, we're adding. You can do that in any order you want, so it doesn't really matter. So that's nice. We did a little bit of something there. Got it. You know, we took 3 things on top and turned it into 1 or 2 things on top. That's an improvement. Kendall?
Secant squared over secant.
Yeah, so next thing we're going to look again at the Pythagoreans. We see that's P3, right? Somebody could confirm that for me?
Yes.
Okay. I know them all. Do I have them all memorized by name or by number? Not, I'm pretty good, but like sometimes I'm like, oh, which number is it again? So we can do that, which is great. Again, we're still in the Pythagorean hunt because we still had like a 1 and then plus something squared. Whenever I see additions and subtractions with things that are squared, I'm thinking to look in the Pythagorean. Now, it's not always going to be there, the one that I need, but like that's the place to start, you know? Most likely it'll be there. And then what can I do with this? So I can just, well, we'd say reduce the fraction. And how would it reduce? It'd just be like secant u, right? I'd have like secant to the first, so just secant, over 1. I'll just write secant. And I'm dunzos here, dudes. What do you guys think on this? Manageable, I hope? I hope. So I have two handouts for you here. And no, I'm excited too. The first one is just like practicing, foiling and factoring, and then I extend that to include some trig things on there, just to practice foiling and factoring with the trig expressions on there. This is not simplifying, but it's like, how we did like the notes 1. This is basically like a practice from notes 1 from last time. And then I'm going to give you a second one that's going to be like practicing the simplifying expressions that I just gave you. And this will be part of Sunday's problem set, but we'll have some time in class to try to get a big chunk of this done, so it's not all on you guys.
Are we gonna have a test next week?
I don't know, man. What's next week?
We have so many tests.
We can't have another one.
You have so many tests next week, you don't want to have another one?
We haven't even got to 5.
Yeah, we haven't even started 5.2 yet, to be honest with you. Before Thanksgiving break.
Yeah.
Well, here's what I will tell you. If I'm sitting here kind of counting things out, I don't think we get to a test day before Thanksgiving break, but we'll probably have homework quiz in there somewhere. But that's like not a big deal kind of thing, right? This is me like guessing right now because I have, you got an extra one? Oh, Julius gave you one. Okay. So we got, I don't know, half hour here? No, 40 minutes here? So like, get some stuff done, make some progress. If we have a million tests coming up, like, get your math homework done now so you're not scrambling Sunday at midnight, trying to get it done. You know what I mean? I know that's rough.
No, I just have to study for my religion test and I have to study for.
Oh,
Yeah, I just read it
Last
last night. I don't know what that means.
Gothic is the pointy ones, Romanesque is the round ones.
Wait, the only minutes we can get that's
Can I go to the bathroom?
Yes, go ahead.
What did we do today?
Oh, that's-